we've been focused on the fundamentals of what a runtime for JavaScript should look like. I think probably of all the problems that we're solving with Node.js, that Node.js probably isn't the right thing to solve with. And it might be where Deno starts to come into its own, is with things like serverless functions. Like if you think about the node model, you install all of this stuff. It doesn't have an out-of-the-box security model. All the things that you don't necessarily want running in your run functions. Where Deno, it's like it can go fetch the stuff. It's not going to interfere with the operating system by default. Got to be explicit about what security permissions you give to it. And there's been people experimenting with serverless functions in Deno. That may be the killer use case. Write them in JavaScript, write them in TypeScript, write them in WebAssembly, whatever, and you can run them on demand in the cloud.
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode cloud servers. Head to linode.com/changelog. This episode is brought to you by Rollbar. Move fast and fix things. Resolve errors in minutes and deploy with confidence. Head to rollbar.com/changelog. Request a demo. Get started today. It's loved by developers, trusted by enterprises, and most of all, we use it here at changelog. Move fast and fix things with Rollbar. Once again, rollbar.com/changelog.
Welcome to JS Party, your weekly celebration of JavaScript and the web. Congrats to the Deno team on their big 1.0 release. This is a wide-ranging discussion about all things Deno, the team's use of Rust, their take on package management, what adoption looks like, Deno's open source community, their code of conduct, and a whole lot more. Hold on to your butts. It's party time, y'all.
Hello to a new episode of JS Party. We have a really meaty, interesting, exciting one today. And before we kick things off, I'd like to introduce the people on this particular episode. And joining me on the panel, we have Nick Nisi. What's up?
Hoi hoi.
And for our guests, because we're talking about Deno, we have Kit, who's part of the Deno core team. Welcome.
Hello.
And I'll leave it to you to introduce yourself, just to talk a little bit about what you're doing, where you're working currently.
So by day, I'm a principal technologist at ThoughtWorks. And so, most of my time is spent advising customers on tech strategy and crazy stuff like that. But as Nick probably knows, I've always had a secret life in most of my career. And the past probably, close to 2 years now has been working on Deno in one capacity or another. So, and a few other things in my past for my sins as well too. I used to be the project lead for Dojo too, but that's in my past.
Nice. So is the consensus that it's Deno and not Deno then?
Yeah, so officially it's Deno.
Okay.
And even though it was unofficially Deno up until TSConf in Seattle last year. So I called it Deno. Rai was calling it Deno because he probably hadn't thought much about it. And then when we met there, he's like, I've been thinking I probably should call it Deno.
That's awesome. And so with that, I guess we'll just kind of dive into what exactly Deno is. Could you give us a really wide overview of what exactly Deno is and what it does?
Yeah. So Deno is a runtime for JavaScript and TypeScript and WebAssembly. And the main intent of it was, so taking a step back, Rai had created Node.js back in 2012. And obviously the whole JavaScript server-side world had transformed a lot due to Node, but JavaScript as a language had transformed, and TypeScript had started to come in, and we had WebAssembly is started to become a big thing. And so I think Rai's motivation originally was that there was just kind of a need to take a step back and take a look at things again and see if there were some improvements and changes that could be made. And then, when I started getting involved, that was kind of the attractiveness to me was, how let's not be encumbered. Let's try to take a look at what we can do with JavaScript and TypeScript, make TypeScript a first-class language from a runtime perspective, and also sort of support modern syntax, modern language, and not be sort of encumbered with, what is that, 8+ years of sort of legacy, right? And that was kind of the motivation. The other real important thing was that one of the big regrets that Rai had with Node.js is out of the box, you have access to everything with Node.js, right? There's no security model built in. And I think we've all realized that security shouldn't be a second, an afterthought, right? And this sort of security first model that, a runtime should have very, very limited access and to the host system that it's on, much like our browsers are, right? There's a good reason why browsers don't allow access to the local system, but only on a very limited basis, right? And wanted to explore that model from a runtime perspective as well, too, and just make sure that, if you try to run something, it won't completely ruin your machine. And then probably the other big thing was to sort of invert the model of what a browser does with what a runtime could do, right? And I've often started referring to Deno as a browser for modules, right? And we've had that model out there where we've had web servers, they've hosted our web pages, and that model works really well. And Deno sort of embraces that model and says, well, if there's a module out there on a web page, I can load that and run that. Why put any other barriers between the runtime and the code, right? You just type in a URL, and if the media type for it is correct, Deno will just run that module, which is kind of a whole different model inverts the model that we have with, for example, Node.js.
Yeah, definitely. I think that's like a very unique attribute of Deno as compared to Node. Before we dive into like the package management piece, I'd like to take a step back slightly and just look at one of the things that I noticed specifically with regards to Node versus Deno. Obviously, there are implementation details that are different, like the permission and security model. But one of the other things that I noticed is the particular language that's used, the implementation internals. So with Node, it's like pretty much C, and with Deno, it's Rust. And I'm curious, what was the decision-making process like when you chose to use Rust?
Yeah, and Rai led most of that. So originally, Deno was the bindings to the operating system were written in Go, mostly because Rai really liked Go, right? And it's a pretty good language, and it really lent itself. I think he hated C and C++. I don't blame him. And so there was a bit where, I spent all that time in Node.js working with C++. It had all these challenges and limitations, and we did it because, V8 was written in that. And so it was an easier thing, but I don't want to do that again, right? I want some language that's going to make things better. And so originally it was Go, but early on, in probably the first couple months, it was like, well, the risk with it is that Go's garbage collected, and then we've got JavaScript garbage collected, and we're probably going to get ourselves into a situation where we're going to have race conditions with garbage collection, and then the runtime will become non-performant, and we're going to have really fine-grained controls over when garbage collection happens, and it was just like this is going to cause us a whole problem. So we need a language behind it that we're going to have the same sort of, that's not garbage collected, right? And we liked Rust. It was an interesting language, and it was like, well, how difficult would it be to move to Rust? And now we just haven't looked back, right? I've had to learn Rust. It's probably the first non-garbage collected, sort of runtime interpreted language that I've dealt with in almost probably close to 20 years now. And, trying to remember all those things. But Rust has been really quite good. I think it's saved us from doing a lot of stupid things behind the scenes because you have to be so explicit about memory management. And I know my early experiments with trying to contribute with Rust where like the compiler just kept telling me, no, you're doing it wrong. No, you're doing it wrong. But usually the compiler also tells you, oh, and actually this is what you need to do to fix the problem, right?
Nice.
So I've really grown to have a lot of respect for Rust, but that learning curve is really, 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 really steep. And so I think the great thing is you've got that sort of security back there, and now that we have plugins that you can write in Rust, you can author additional code in Rust when it gets really heated and that sort of thing, but you can spend most of your time working in something that's a little bit more easier to develop with in JavaScript or TypeScript. And I think that's one of the big advantages there as well.
That was going to be one of the questions I asked, is if I wanted to get in and contribute, how much Rust do I have to learn to do so? And I was looking at the GitHub repo, and it looks like 63% of the code is TypeScript, and then only 33% is Rust. So it still seems like there's a lot of room to get in there if you just want to code TypeScript.
Yeah, and I think it's evolving, right? I think one of the things is we're continuing to find, JavaScript is always going to have its limitations, right? TypeScript is always going to have its limitations, right?
Right.
And so we're finding, and that this is kind of one of the big focuses, is how much can we start to pull out and move into Rust, right? Because once it's hardened, and the long-term vision is how do we actually make that easier for end users as well too, right? That's kind of always the vision is maybe do a really dirty prototype in JavaScript, harden it a bit in TypeScript, incrementally evolve towards that. And then, when you've got hot paths where you're doing huge amounts of computation and that sort of thing, try to be able to make that easy to seamlessly move over to Rust. And we're not quite there yet, but that's kind of the medium-term, long-term vision with it is make it super easy to just move stuff over there. From the internals perspective, there's just some things that are always going to be easier to do in JavaScript. And V8 is a phenomenally great engine at optimizing really stupid code. Sometimes it obfuscates a lot of our bad performance choices, but I think we're beginning to move bits and pieces of the TypeScript compiler actually out to Rust, and we're trying to use the TypeScript compiler less and less over time, which is another interesting topic.
Yeah. So does that lock you into like a specific feature set of TypeScript or like a subset of it? How does that work? How does upgrading TypeScript work when you're rewriting parts of it?
Yeah. So the big thing we're moving out at the moment is the dependency analysis, right? And we've had to, because like module resolution in Deno, because we support remote modules, because we are explicit about the extension name on all the modules, we've had to hack the TypeScript compiler a bit. So for a long time, the module resolution had always been sort of custom code, and TypeScript compiler is configured that way to be able to swap that out. But the problem is that TypeScript compiler works completely synchronously, right? The reasons for that are back in the annals of the fact that we didn't really have good asynchronous programming models in JavaScript for a long time, and some of the APIs that were required needed to be synchronous, and so that loaded through the whole thing, right? So that means that when TypeScript goes to try to get a file to pull it into the compilation, it's a synchronous process. That's really bad if you're remotely fetching modules. And so what we had to do is refactor it so that we used the uncommon TypeScript API called preprocess file. It's only on the compiler. It's not, it really was intended for in-browser usage, or like in VS Code and language services where you want to quickly run over the file, figure out what files you need to go fetch, right?
Yeah, I think I've used that before.
Yeah, so we currently are using that at the moment to go figure out the analysis of what files that we need, and then we send that whole bit to Rust, and then Rust will go and fetch any modules, cache those modules that are needed, and hand that back. So before we invoke the TypeScript compiler, we asynchronously resolve all of our dependencies, and then we just create all of the source files and hand that over there. Now the problem is there's some long-standing issues with that because it's not a popular API, and so it's broken in a couple ways that cause us grief and havoc. Like for example, string literals that look like they are importing a module get caught by this preprocessor, right? As well as there's another weird, strange. Well, it's not really a bug. Is that preprocess does a really quick pass on things, but the TypeScript compiler does obviously a full AST parse and it gets down into the depths. And so with dynamic import, for example, it will find some static strings. Like if you set a string to a variable and then you pass that variable into the dynamic import and say import, this module variable, the compiler will detect that and say, oh, I can pull in the types for that and, do the analysis of that. And so it'll identify as a dependency where the preprocess imports doesn't see that node. So you end up getting cache mishit. And so we've got a defect with Deno at the moment where we don't find all of the dependencies. Anyways, the whole thing is that's a lot of work. And so we've moved that out. We're in the process of moving that out to Rust. And so we're going to do all of that dependency analysis. And then what we're going to do is just say, here are all the files, TypeScript compiler that you're going to ask for. Now, Rai and Bartek and I have looked at how to even begin to start saying, well, what if we did the AST processing? Because that's computationally heavy. It's really inefficient in JavaScript. What if we were able to do all of that and then hand that to the TypeScript compiler, right? I think we don't, like the actual language enforcement and the type enforcement, we would probably never want to not use the TypeScript compiler for that, but we want to chip away at everything else around it that is computationally heavy, that is just wasted, right? Like the transformations, like on emit, if we're going to do any transforms, and we only do, really, because we support, very, very modern ECMAScript, right? Whatever V8 supports, and V8 supports things in advance that it takes a long time to work into browsers, right? We had top level await before before anybody else did, right? Simply because it was in V8 and we could get it in there. So we don't do a lot of transforms with the TypeScript compiler, but obviously things like experimental decorators will always be transformed forever. So if you need that requirement, there's a few things that we have to transform. But there's this other project which we got onto that is called SWC, and it effectively is a JavaScript and TypeScript AST compiler and transformer written fully in Rust, right? And it is super, super fast. I mean, it is orders of magnitude faster than the Babel and the TypeScript, AST compiler, right? So, the target for SWC is really to kind of replace Webpack Babel in Rust, right? So it's kind of doing that heavy lifting. It can strip types out of TypeScript files. So it doesn't enforce types, but it does the type stripping, which, Babel can do as well. And then it emits stuff, and they're beginning to implement the sort of Webpack type of things, right? And it is super, super fast. And we have that integrated into Deno at the moment. The main purpose that it serves today, it does two things. If you use Deno doc and a module, it'll read the JS doc and emit a text thing to your console of the documentation for the module, right? And if you do it with --JSON, you'll get a JSON blob emitted out from it, giving you a documentation structure for that. That's all powered by SWC. And then the other thing in Deno that heavily uses it at the moment is that we had Prettier incorporated into Deno. So you do Deno FMT format and it'll reformat your modules for you. The problem is Prettier not being Rust is pretty darn slow, and it was a lot of stuff to load in to Deno. We were lazily loading it, so we'd go and fetch it and run it, and it was just becoming a bit of a pain. And so David Sherritt, who was written a couple really awesome tools, wrote dprint, built based on SWC, so 90% of dprint is in Rust, which he usually moves to WASM, but we've integrated it directly into Deno. And so, Deno FMT is pretty darn fast in reformatting files. Yeah, and you can reformat your whole project code with it.
Linode is our cloud server of choice. Grab the Nanode plan for just $5 a month, just $5. That gets you a gig of RAM, a blazing fast 25 gig SSD, and 1 terabyte of transfer. Let's be honest, you can go a long ways on that $5. When you do need to scale up, their prices are predictable, so you can put your calculator down. You won't need it. We've been running changelog.com on Linode for years, and we've always impressed by their award-winning support team. Check them out at linode.com/changelog. Once again, that's linode.com/changelog.
All right, so we talked a lot actually, about just TypeScript, Deno internals, and so on and so forth. One of the things I wanted to focus a little bit of attention on is when you mentioned the implementation details with regards to V8. And from my understanding, a lot of how Deno works is through this concept of V8 isolates. Can you speak more to that and how exactly that affects the runtime within Deno?
Everything that uses V8 works off of isolates, right? So an isolate is effectively that sort of sandbox that you get when you run JavaScript in your browser, right? So it's the sandbox effectively, right?
Yeah.
And so we create and manage those isolates and within V8, and you can do some crazy things with them. And this is usually the way things work within like Chromium in your browser is a lot of the built-ins that you get from a browser are sort of injected into the isolate. So you have C structures that you sort of project into the isolate, and that's how you get a lot of additional features that aren't part of the V8 or part of ECMAScript language specification. We don't use a lot of that within Deno. Most of the runtime type of browser capability APIs that we have in there are written in TypeScript. And if they need to go and do something in the operating system, we will, what we call in Deno languages, we'll do an operation or an op to Rust, which is then that secure channel to outside of V8. And there's basically an array buffer of shared memory between the sandbox and Rust. And we have opcodes that go over that, and there's in the technical details there's two different types of ops. There's sort of a raw op, which we use for performance reasons, but most of the time a lot of the lighter weight or non-performance problem ops or JSON goes across that buffer, and we serialize it inside the sandbox, and then we send it out in Rust and we deserialize it in Rust, and that's how we communicate between there. And then the communication between V8 and the JavaScript and the sandbox, there's only very little bit of communication there. Most of it is to bootstrap up, and then once we're up, we're in the Rust to JavaScript communication.
Cool, that's interesting. So then, like, kind of going off of that, can you speak more to, like, how exactly package management and resolution works? Does that happen at the V8 level, or does that happen within Rust, or where exactly are you doing that particular?
It's complicated.
Okay.
Yeah. So what happens is we do a lot of legwork in Rust, right? So for example, when you give a module, and let's say you start on the command line and you give it a module, right? What we will do is Deno has a built-in cache, which is controllable, so you can move it around. It defaults to a particular location, and if you do Deno space info, you'll get the information of where that cache is located, and you can go and introspect that, right? So we get that module, and the first thing we do is we figure out, hey, are you trying to refer to a local module or a remote module? And this is all happening in Rust, and so we do a bit of work there. And then once we figure out the absolute path for that, be it a web server or a local file, we look in the cache and say, hey, have we seen this file before? And if it's in the cache, we'll pull it out. Then at that point, we start to look at, is that a JavaScript module or a TypeScript module or a WebAssembly module, right? And we figure out what to do with it from that point. If it's JavaScript module and you haven't told Deno that you want to type check JavaScript modules, we'll hand it over to V8 and load it as a ES module, right? Everything in Deno is an ES module. And so we'll hand it over to V8 as a module. V8 will then do analysis of that module and say, here are the other modules that are being requested. That comes back to Rust, and then we'll go off and fetch all of that, right? And if they're all JavaScript modules and they're locally cached, nothing's happening except we're pulling stuff out of the cache and handing it over to V8 and loading it up as a ES module, right? And then V8 will all do that. Now, if you hit a TypeScript module, what happens then at that point is we go, hey, do we have this transpiled already in the cache? And let's say we don't, then what we'll do is we will then lazily instantiate the compiler isolate, which it's effectively a web worker that sits there. It's been snapshotted and built into Deno, so it's not like we have to load the TypeScript compiler into memory and all that sort of stuff. It's sitting out there already stuck in effectively a virtual memory that's been snapshotted and part of the Deno binary. We'd load that into V8 and just say, hey, V8, don't compile anything. Here's the last point of restore for that. And then we send a message to that compiler that says, hey, here's a TypeScript file that you need. At that point, TypeScript will go and say, well, here's all the other files that I need to be able to process the types of that. So it'll do a whole dependency analysis and dependency graph at that point, and then it will sit there and do a compilation of those files, and it'll come and give us the JavaScript for each of those files, which we put back into the cache. And when that's done, we load that TypeScript module that's now JavaScript into V8, and then V8 goes back over it all again and says, oh, well, look, I needed this module and this module and this module, right? And those all get loaded into V8. But at that point, they're all in the cache, so it's quite efficient. And so, yeah, there isn't any external metadata that Deno uses to resolve modules unless you're using the -- import flag, which we've marked as unstable because even though we've based it on an emergent web standard, import maps is kind of not really taken a hold well, right? And it's probably, sadly, it's at risk of like not going anywhere, right? So it's had a kind of a bumpy road. It came out, the KV store it was something that Chrome had, sort of gone forward with, and we're like, oh, okay, we're gonna do this, and that required import maps, and it required the built-in modules, and now everybody's sort of kind of a year and a half later kind of like not too sure about that, right?
Yeah. So
we made a hard decision before 1.0 to mark import maps unstable, but already ecosystem had kind of built up of, because we're, Rai, myself, a few, a lot of the core are just not, think package managers have caused us more headaches than good, and we're trying our best to solve problems without resorting to a package manager, right? And people have started to use import maps as kind of a pseudo, package manager. And now we see the problem is now people can't agree on what things are, and the standard, we'll have to see if the standard actually takes hold. We need some sort of problem because, as browsers start loading modules, some sort of solution, because modules start loading in browsers more and more, you need the ability to change where those modules are located. It's something that we've always struggled with. And the problem is nobody can agree what the right way to do it, though, is.
Yeah, there's always too many opinions on how exactly things should be implemented. I think that's what happens when everyone has opinions. Can you speak a little bit more to if people are using Deno now or in 1.0, which I imagine is when this particular episode will be aired, how exactly would they use packages within Deno? Because there is no sense of like a package manager.
The thing I like to say is Deno is a browser for running code, right? So the biggest thing I think people have to do is change the mental model, right? We don't think about it when we open up a browser and we type in a URL. We don't think about it, right? We just take it for granted that when we go to a website, that the page may have changed, but what we're getting is we're getting the version of the page that has the right content, right?
Yeah.
And that is really the mental model that we kind of have with Deno, right? Is, you go to a website that has a module and you give it the URL and you have a level of trust. But again, like if you go to a dodgy website that adds malware to your thing and huge amount of pop-ups and that sort of thing, you go to websites that you trust, right? If you go to a dodgy website and you get malware, we've all been there before, right? But you go to the websites you trust. You use web applications that you trust. You go in, you log into your email on the web, and you have that there. And there's things like HTTPS and other things that are security to let us know that that's a website we can trust, right?
Yeah.
And the current model is that the thing is with package managers, it's sort of, we've abdicated a lot of our responsibility of us as developers of saying, because if it's on NPM, I can trust it, right? And that is wrong, right? And the thing is it's also, which is a model that bugged Rai, and it was one of his big regrets, was that it was a centralized authority, right? And it was a centralized authority that wasn't open to introspection, right? And, obviously NPM is, it's changed, it's been acquired by, GitHub, but that doesn't necessarily mean that they have to be any more open, right? We hope that they are, and, history has been pretty good, but in that space. And again, then people who are looking for a return on investment based solely on whether they manage packages or not, right? There's a much bigger ecosystem that they're now a part of where they're not the sole source of revenue. So that's a good thing, but still we're putting, why do we put that trust in there when, Deno, we always want to explore the model where we get to choose who we trust, right? And we don't have to be dependent upon it, because if NPM registry were to go away today, and there's been, even a couple weeks ago, a silly mistake on a package and half the internet goes down, right? How do we avoid getting that in the situation is not to put trust in a single entity like that, and to diversify that trust. And so Deno just has no assumption. And this is what a lot of people have, is like Deno just doesn't have assumptions, right? If it's a module on a website, Deno can access it and download it and cache it. Now, that means that it's up to us who host the websites to put any logic in there about how we resolve things, right? And so instead of having to sit there and sort out all of this on our local machine across thousands and thousands of machines, right? In the Deno model is it's the server serving up the modules who sorts out the stuff. And there's two CDNs that are really useful for Deno at the moment. There's pika.dev/CDN. That's probably the most useful one. So you get all the sort of semantic versioning that you would want out of NPM modules. And pika.dev CDN in particular has two big advantages. One, it only deals with ES modules. So it goes through all the NPM packages. It looks for ones that have ES modules. And then what it'll do is it will bundle it all up as a single ES module so that you don't have other dependencies inside that module, and you have the whole package there ready to go. Obviously originally intended for a browser, but because Deno works like a browser for modules, it's basically perfectly packaged there. The other cool thing is Fred, who is kind of the ringleader behind it, worked with us, and we were like, well, how do we, we have all of this TypeScript code out there that's been transpiled to JavaScript and bundled up, and we have all these other types that are out there available in @types and through definitely typed. How can we sort of allow Deno to access those types and allow people to safely develop off of stuff in TypeScript on code consuming those packages, but not have the overhead of doing all of that transpilation and take the advantage of the fact that it's already bundled up. And so what we added to Deno is a feature where if the remote server sends a header called x-typescript-types, and it has the content of a URL, Deno will go off and fetch those types and use that in place of the JavaScript when type checking any work that's consuming that module or package, right? So if you go to pika.dev and you find an NPM package that you want, most of the time, and there's always caveats with it, it'll work under Deno. You'll just be able to import it. You'll get type safety. It works like beautifully, right? The other sort of awesome CDN out there for Deno is jspm.io, and JSPM, the biggest thing is it doesn't serve up the type headers at the moment, but what it does is it takes all the other sort of non-ESM parts of NPM and packages them up into a bundle that is compatible with browsers, and therefore it's largely compatible with Deno. And you get a lot of other packages out there, like you can React off of JSPM, you can do server-side rendering in Deno with that, and there's other stuff there. So, because there's all these solutions out there, and again, that provide this information, including semantic versioning resolution of the URLs, why would we need a package manager?
Yeah.
I was going to bring up a question from the chat room. Corbin asked if the way of loading modules like this, would that work for loading private modules? Is there a path to do that?
So stuff that you don't want publicly available, I'm assuming? Yeah.
Right.
So obviously you can load local modules, but any HTTP server or HTTPS server is a target, right? So if they're private modules and you've got a corporate web server, right? Instead of paying somebody to set up a web server for you, which is effectively what a lot of the private registries are, you set up your web server and you put your modules on there that you want, and module resolution. I think post 1.0, there's a couple prototype sort of package servers out there for Deno. I think we'll probably see more of that in the future and get that a little bit hardened and that sort of thing. But, it's basically all you need is a web server, right? And whatever sort of resolution logic that you want to code into that web server is what you do, right? We have, so from a public perspective, Deno.land/x is kind of the big public registry at the moment, and you can add your packages there. And most 90% of it is all sitting there on GitHub, and basically we redirect the URL to the package on GitHub, and then it pulls down the code, right? But private stuff, you just set up a web server.
Nice.
That's how you do private.
Also, I noticed that talking about like modules and so on, Deno also has standard modules. So what can you currently do using standard modules within Deno?
One of the challenges is, even though JavaScript has moved forward quite a lot in the last few years in adding a lot of standard library functionality, it's probably still lacking. And so the standard modules, the STD modules in Deno, solve some of those things that are a little bit harder to do. That probably should be part of some standard library for JavaScript, and I know we keep talking about that as a community. And so there's a whole bunch of stuff in there. We've tried to take most of that direction from Go's standard library, right? And so Rai's opinion, and I'm not overly familiar with it, but in a lot of other people's opinion, was that Go has a pretty decent standard library, right?
Yeah.
And so a lot of the Deno's standard library is based off of the Go APIs and models, and then there's a few things in there that we've just found generally useful that we think should be there instead of people reinventing the wheel, right?
So a lot of them are promise-based too.
Yeah, and a lot of async iterables, right?
Yeah.
So we try to always go, hey, let's use modern JavaScript syntax when doing this, right? So we prefer async iterables. We prefer promises, heavy use of async await, and most of that, right? And just try to make it a bit richer, right? So, there's a basic HTTP server. You'll find a decent amount of similar stuff to what is the Node standard, modules, as well as there is the standard /node, which is in a growing set of sort of polyfills, for lack of a better term, for Node to make it easier to consume Node modules natively, right? Though personally, I'm not a big fan of that, because if I wanted to use Node, I'd use Node, right?
Mm-hmm.
The thing is there is a large, Node ecosystem, and that will always exist. And, some people say, oh, is Deno out to replace Node? And it's like, well, I don't know. Rye's intention wasn't that. I think Bert Bedler is probably a bit more eager. He's probably the one who's like the most, we're going to get Node, but I think most of the rest of us are just pragmatic, right? We just want to make it work well. And hey, if people use it, that's great. We're just trying to do the right thing, but don't drop Node today, right? We're not even at 1.0, and we probably will be by the time this airs, but there's 8 years of heavy investment in that ecosystem, and Deno's definitely not going to replace it anytime soon.
Yeah. All right, cool. So with that, we'll wrap the second segment. If you have any last thoughts or anything before.
Yeah, don't use package managers.
That's a good one. I mean, I think I don't want to speak for everyone, but at the same time, I do think that most JavaScript developers, that's the part they hate the most. It's just fighting with package managers and NPM, and even just like dependency trees and lock files and the whole
Yeah, but the number of people who are like, yeah, but then I want that. And it's like, well, do you really? It's like there's probably a few things that are still hard to solve, but we're wanting to, that sort of last responsible moment of making a decision, right? We want the problem that we can't solve another way, right? People were like, well, how do I increase the level of trust that I have in those remote modules? And it was like, well, I need to know that the server isn't like changing its answer and that sort of thing. And so, part of it is that cache can be immutable. You can check that cache into your source code tree, and then you'll never end up going for a remote module. There's a Deno command called Deno cache, which will go and fetch all those modules for you, put them in the cache, and transpile them, do all that work for you, and then you can just take your Deno cache, you can lock that in there, check that into your repo, and now you're never dependent upon anybody else at all. The other thing too is like if you are, there is package locking type of thing where we take a hash of it, and you can have, like, if you don't want to move all of those modules, but you want to make sure that you're getting those modules downloaded somewhere else reliably and that they haven't changed, that you can use the lock, and you can then use that, distribute that lock file to allow other people to make sure that they get a repeatable build out of it, right? So those are things that we didn't even have those originally in our package management. They were added in, and so, implementing the solutions for the right way are there. The model's like completely wrong, right? We have these things called computers which can retrieve files for us. Why do we need another command to do that, right?
Yeah.
What would you be caching? Is it stuff like, for example, that you'd pull down from Pika then, and then cache and check into your project?
Yeah, so Deno cache contains the original JavaScript file, the headers, because those actually become important, like those TypeScript headers that we talked about earlier, the type headers, they become important. Plus there's redirect, we follow redirects and all that sort of stuff. So in order to be able to rebuild that locally and make sure we get the right module and all of that sort of stuff, we have to keep the headers. And then again, if it's originally was a TypeScript file, we will, and we've transpiled it to JavaScript, we will cache that in the cache as well. But that's all just laid out in there. So again, if you do Deno space info, you'll see the location of your Deno cache, and you can go in there and look at those files. But it's all persisted to the file system, and start up again, we just simply look and say, if we resolve to this URL or even a local path, is that in the cache, right? And we take a look in the cache. If it's in the cache, we don't go fetch it.
Cool.
Local files will be invalidated based on their timestamp. One of the things that we probably have longer term is that we don't check the E tags on files and then validate remote modules based on E tags, which we probably should want to do. So right now, basically, if you fetch the remote module and it's in your cache, we will never go try to fetch that again unless you do the -- reload, which will say, I don't care what's in the cache, just go and fetch it all again. But local modules get invalidated based on the timestamp of the file. So if you've touched the file and it's different than the cached timestamp, will invalidate the module and reload it.
This Don't Call It Jeopardy style game show will be played at Half-Stack's online conference on Friday, May 22nd. If you answered what is JS danger, you are correct. We'll be at Half-Stack Online. Hope to see you there. Tickets are $19 cheap, and you can get them at halfstackconf.com/online.
Now that Deno is officially 1.0, what would you say is like the adoption strategy in terms of using it? Because there's a lot of modules, as you mentioned, that are not fully compatible with, like, you can't use npm with Deno, which means that you can't use, your favorite package with it necessarily. So what would you recommend that approach be like?
Yeah, I mean, I think it's probably, it's still going to be experimental for a lot of folks, right? I think we need, as a community, to see where things head. Hopefully 1.0 will give a stable enough base for the ecosystem to build up a little bit more. And like, for example, I've been starting to rework on, I've got a Koa Express server framework, middleware framework for Node called Oak. And now that we're, at 1.0, it's given me the opportunity to bed down a few things in there and add features to it and, get it a bit more stable. Because I think for a lot of people, it's going to be like, well, what kind of workload do you want to run with it? I mean, it's been early adopters that have been doing stuff with it. And there's some really interesting stuff out there. But hopefully 1.0 over the next 6 months, we'll start to see more and more stable, more and more enablement and tutorials. Because as any of us that have been through Node.js or even browser end development, there's still a learning curve, right? And so there's going to be a learning curve with people in Deno. And it's one of the harder things for me to answer because my head has been in that space for 2 years. So I know how things work. And I was actually taking a step back yesterday as I was starting. I'm like, I have to explain with Oak, I have to explain some of the basics of Deno to people to get them to understand, right? And I have to walk them through that, right? And so I think as a community, we probably need to learn what it takes to enable people to do that. And there are a few things where people are starting to educate other people on it, and we're starting to see tutorials and that sort of thing. So I think the next wave will be those that are really interested in understanding the mechanics of it that will then start to enable other people, right? And so there are some really good experiments with server-side rendering with React at the moment and Preact. People are running into problems where you're like, okay, well, this doesn't like doing that, and this type, and when I load it off of JSPM, it blows up, and there's all these sort of crazy things that we probably have to iron out. So I still think it's going to be for the brave for a while, and so I think it'll be a while before we see mass adoption. But I think it's 1.0 is going to be the point where you can safely experiment and realize that, which is the world we've been living in for the last 2 years, right? Is every week we've been through 47 releases, 47, 48 releases. And pretty much every one of them has a breaking change in it, right? So, like up to this point, it was like you upgrade the latest version, and who knows what of your code didn't work now.
I think, as you mentioned, you mentioned this previously, but one of the biggest things, especially with regards to talking about Deno and like with a lot of content that's coming out around this, that will help with adoption. I think a big one is definitely kind of talking more about the fact that Node is like sort of a comparison, but not a direct comparison, because I think oftentimes that comes up is like, now I have to migrate. And I've even seen this in Discord where someone is like, I want to write this in Deno, I'm migrating from Node. And it's like, that's not necessarily what Deno should be messaged as, because it's sort of different. It adapts a lot of the modern JavaScript and modern module management. So from that perspective, I think it's really exciting to see, because it's a different approach for how we do things. It's sort of questioning the base premise of how we've been doing things and sort of saying like, this shouldn't be how we do it. Let's do it a different way, which is why I'm excited about the project, because I think it's really cool to see that happening.
I think part of it is we've been focused on the fundamentals of what a runtime for JavaScript should look like, right? I think probably of all the problems that we're solving with Node.js, that Node.js probably isn't the right thing to solve with. And it might be where Deno starts to come into its own, is with things like serverless functions, right? Like if you think about the Node model, right? You install all of this stuff. It doesn't have an out-of-the-box security model. All the things that you don't necessarily want running in your sort of run functions, right? Where Deno, it's like it can go fetch the stuff. It's not going to interfere with the operating system by default. You got to be explicit about what security permissions you give to it. And like there's been people experimenting with serverless functions in Deno. That may be the killer use case, right? Write them in JavaScript, write them in TypeScript, write them in WebAssembly, whatever, and you can run them on demand in the cloud, right? A lot of people, the other thing that's kind of emergent is that hybrid runtime application doing transpiling of code for the browser, right? And that probably needs a bit more work, because we have made the TypeScript compiler APIs available in the runtime. We've now moved them behind the unstable flag, because we're going to rework them. But you have something where you can consume TypeScript code. You've got the TypeScript compiler in there. You can serve that up. You can do some server-side rendering. You can serve that up to your clients, all that sort of stuff. And for a browser, you can even create, it's not efficient, but you can get the Deno to generate a bundle of JavaScript code based on TypeScript code in several modules and send that off over the wire to a browser as a single file. And so I think we'll see stuff there. And I think there's some interesting experiments of the, why don't we do Electron type stuff based off of Node? And there's some early work in doing some bindings to Chromium and merging that with Deno. But I think that's got a ways to go before we see, the Deno Electron. And
so going back to just mass adoption and migration, one of the things that I notice a lot, because personally I really like open source. I like the ideal of open source. I think it's wonderful. And for me, part of it is also just the importance of community. And you brought this up, as the community is what will drive the overall mass adoption of Deno, or just making Deno become the standard or how people build things. Alongside that, I just wanted to think a little bit about how, or at least ask the question, which is, how is Deno working towards building a community? Because one of the things I did notice is that Deno has yet to have a code of conduct. And I don't know if this is generally standard, right? At this point, I know there's always arguments around people should be decent, et cetera, but one of the things I do notice is that from a baseline perspective with open source projects, that generally tends to be a way of setting a standard and providing and fostering a more welcoming community. I'm just curious what your perspective is on that.
So yeah, my feelings are probably align well to, I think, your feeling, right? And it's probably something that I need to approach with Rye again, right? I think Rye's always a bit hesitant to wade into anything that isn't code. And, I respect that, right? If we could take humans out of code, I think probably Rye would be happier.
Yeah.
And I think a lot of us would, right? And, I think as I've gotten to know Rye over the last couple of years, he really is the heart and soul of Deno now at the moment. And I think he understands the importance of well-functioning community. I think it's something that we're going to have to talk about as a core team more of how we do that in a way, programmers and, those type of behaviors are completely unacceptable, right? And shouldn't be tolerated. We actually just had a little bit of a conversation earlier this morning is there was an inappropriate comment recently in there, and we don't have the it would be great if we could all just get along and not have to worry about stuff like this, but there are individuals who will always come in and ruin it, right? And I think you're right, is we're getting to the point where we've got enough of a community that we need to be explicit about respect and make sure that people understand that certain behaviors are not tolerable. I haven't had a point conversation with Rye and the rest on that, but I think that you're right. The time has come, and we probably need to talk about that and make sure that things are well understood of what's acceptable behavior and what's not.
I really appreciate your honesty with regards to this. And I have to say that, and this is me, I think very highly of your team. I've done a couple of PRs at this point, and I'm not an expert at all in Deno, and I'm not a key contributor in any way, but I think the way that I've interacted with the core team has been fairly professional, and I've appreciated that because I see that intention, the good intention that the team has in terms of fostering the community and making sure that PRs are attended to, especially if they are from first-time contributors, which I was at one point as well. And I think that's absolutely wonderful. And I think there's a lot of potential to grow and to keep that baseline of a strong core foundation, because especially from a new open source project, when you're thinking about building a community, you want to make sure that you start from a really strong core, as you mentioned, because then overall it just leads to so much a wealth of people wanting to contribute, people being excited about the framework, putting their heart and soul into it, and overall it leads to good growth. So that's wonderful to hear, and I really appreciate you sharing that.
Yeah, and it's really interesting because Rye is definitely the core. The only sort of person that sort of came along for the ride, so to speak, that that was Bert. So Rye and Bert and were there, right? And the rest of us that you would consider core, and it isn't even a formal organization, right? It's just there's those of us that have been around for a while and sort of come into it. It was all self-assembled, right? So from a open source community, right? It's strange. It's sadly all male at the moment. It would be great if we had, but it evolved organically of its own, right? It wasn't like, hey, you're a core contributor,
Yeah.
It was just those that were interested. I will admit every once in a while I take a look at the contributions bit of it, but if you look at the contributions on GitHub, the core team pretty much is reflective of the level of contribution, right? And that's the kind of the way that it follows. But, Bartek, overtook me on contributions, at the moment, right? The formal core is Bert, Bartek, and Rye, are the ones who are meeting regularly. Bartek has the time to dedicate to it. Me being on the opposite side of the world, somewhat lives, and I still have to do my day job, which lives in. Kevin's on the west coast of the U.S. I think Berkeley. And he's been dragged into coursework, and so he's not been able to contribute as much. But yeah, it's an interesting group of which almost all of us are just focused on the coding aspect of it. But yeah, even recently we've had to have conversations about bad behavior. He's like, why do people do this, right?
I think that's the thing, right? Oftentimes I've even talked with people about this where I'm like, code is very important. I'm not even going to disregard that. That is true. But I think community is also important because I'm like, people are going to use your code and they are the people who make up the community, right? And ultimately, like, those two go hand in hand. And assuming, like, I'm not a pessimist in general, but I think working in open source has made me fairly, like aware of the fact that assuming good intentions is like one thing, but as you mentioned quite clearly, there's always going to be the one person who has like makes an inappropriate comment or does something that makes someone else uncomfortable and drives them away. And I think for me, when I talk about like a code of conduct or something, it's not saying like I'm going to police everyone to act in a specific way. And I think that's what people assume. It's more just assuming like this is the baseline interaction of what we expect. And it's also useful as a sense of pointing to, because now you can be like, hey, you did this. This is the code of conduct. They don't match. What is the best course of action now? Like, do you get kicked off Discord? Do you get a warning? Like, what is next? And I think that's useful because now it's less about you hurt me or you said something that was insensitive to me, but it's just a general like, hey, this is a whole community. We're all in this together. And we've all agreed to act in a specific way and you have not. And so on.
Yeah.
Yeah.
That's the thing is the codes of conduct don't exist because people want to be, maniacal. It's because people behave badly, right? It's like, why do, it's like we didn't, people don't sit around going, oh, I should write rules about, because, no, it's like people have to say, don't say stupid things. Because people say stupid things that are hurtful. And it's like, what? Oh, and you wish, I think everybody wishes that we wouldn't have to.
For sure. But it's good to see that the team is really looking towards considering it. And with the 1.0 release coming up, that seems like a good time to start focusing on community and building that, because this is, now that it's 1.0, people will start really taking a look at it more as a project. In terms of like adopting it for side projects or even adopting it for full projects going in, now that it has that 1.0 stable release on it. That's really good to hear that it's something that's being taken seriously. And if the project grows in the way that Node has grown, which hopefully it will, it seems crazy that it wouldn't have anything like that. So it's good to hear that it's something that can be looked at in the future.
Awesome.
Yeah.
Yeah, and I think the other thing about community is wow, people have lots of crazy opinions too, right? And it's like I was getting really frustrated. I remember I was like, well, that is open source community for you, and it's like, well, that's the stupidest idea I've ever heard. And it's like, yeah, how do you respect? And there are still some crazy people out there. I mean, I'm sorry if some of you are listening to it, but that I would consider crazy. But yeah, there are some really varied opinions about. It's been such a large group of people of interest, right? I mean, I think this is one of the weird things is because of the history of Rye, and like you look at how many stars we have on GitHub, and it's there's a huge amount of interest in it, and that means that all manner of individuals, sort of have come and go into the community, right? And there are some very strange views on, technical views on what Deno should do or not do. And it's like, whoa, and metering that sometimes. And what people feel is a useful contribution also varies as well too, and you get the one, the one-line statement in a title for an issue and no content at all. And it's like, that's not useful.
Yeah, totally.
Definitely.
Well, we're all super excited for the release. Congratulations to the team, and we're looking forward to more. I think that is a great place to wrap for this particular episode.
Thank you for listening to JS Party. We appreciate your time and your attention. If this show has informed you, entertained you, or given you joy in any substantial way, please tell a friend. Word of mouth is the #1 way people find podcasts they love. Special thanks to Kit Kelly for joining us today. Give him a shout at KitsandK on Twitter. This episode was hosted by Divya and Nick. Great job, y'all. It was produced by me, Jared Santo. And the music you're hearing right now and throughout all Changelog shows is created by the mysterious Breakmaster Cylinder. We have awesome sponsors who support our work. Thanks to Fastly, Linode, and Rollbar. That's all for now. Dojo next week. A little birdie told me it might be better than React. Talk to you then.